All right, so now we're going to talk about Chapter 10, hypothesis testing with two samples. Okay, so Chapter 10, hypothesis testing with two samples. All right, so we use this to compare when we have two groups. And this is most often used because usually we have something like a control group or something like that. So usually two groups, and so we can compare the two groups, especially with the placebo. Okay, so when we're talking about these, we're going to compare two means or two proportions from two groups. They are independent or matched pairs. Okay, so those are the two types. Independent groups are groups that are independent, so that they are in no way related to each other or their sample values selected from other populations. So they're independent groups. Matched pairs consist of two samples that are dependent. Okay, so if they're dependent, that's matched pairs. If they're independent independent groups. Okay. So now if we take a look, independent groups, you have tests of two populations and tests of two population proportions. So we can do means and we can do proportions, and our samples are independent. If we have a matched or paired samples, those samples are dependent. Okay? They test two of the population proportions by testing one population mean of differences. So we're going to use differences on this one, and we'll go into that a little bit more in a minute. So in section 10.1, two population means with unknown standard deviations. Okay, so they are simple random samples from two distinct populations. Okay, so we have the sample sizes are small and the distributions are important. They should be normal. So we have normal distributions. If they're large, then they don't have to be normal because we can use the central limit theorem to use the normal curve to approximate them. So if they're small, we need them to be normal, but if they're large, it's okay, we can approximate them with the normal curve. And we are going to talk about the difference in the sample means. So that's how we're going to use it. We're going to use the difference between the mean of sample 1 and the mean of sample 2. So it's the mean of group 1 and group 2. Example 10.1. So on this one we have data about the amount of time that boys and girls aged 7 to 11 spend playing sports each day. So we have boys and girls, their means, and their sample deviations. All right, so we know that they're believed to be the same. So we're thinking that they spend the same amount of time outside playing sports each day. So, they should be the same. That's what is believed. We have the study, we've collected the data, and we're going to compare these two groups. So the means of these two groups, times of boys and girls for ages 7 to 11 play sports each day. So we're going to test this with a 5% level of significance. All right, so we have our girls are independent from our boys, so this is independent groups. Now we're going to take saying that the null hypothesis is that they are the same, so that there's no difference between the mean hours that girls play versus the mean hours that boys play. Now the alternative would be that they are not the same. Okay. Now, but because we're comparing two groups, we use the differences. So we're going to subtract the girls and the boys to get our differences. So if they're the same, they would equal 0. But if they're different, the difference wouldn't equal 0 when you subtract them. All right, so when we come to this hypothesis test, we are going to use this to help us decide. Even though we have two samples, we still use this to help us decide. So we have a mean, we have an unknown standard deviation, so that we can do a required check. We can check and make sure that it fits, and then that tells us we're going to do a t-test. But because we have two samples for this, it's going to be a two-sample t-test. So you go to your calculator, and you're going to go down to the two-sample t-test. So we use the decision chart to get to the same spot. Now I'm going to put in the statistics. So I've got the girls is my group 1, so their mean was 1, sample mean was 1, sample standard deviation 0.866. and they had 9 in the sample. For the boys, it was 3.2 for the mean, and the standard deviation for the sample was 1. And they had 16 boys sampled. Now, on this one, this is going to be two-tailed because we just need to see if they are different. So we're saying not equal to each other. We don't want it pooled, and we're going to calculate. And our p-value is 0.0054. So because this is two-tailed, that 0.0054 gets evenly split on the right hand and on the left hand. So the right side and the left side. Now we're going to compare the p-value to our alpha, and our p is less than our alpha, so if p is low, the null must go. So our p is lower, so that's going to tell us to reject the null hypothesis. That means we're going to reject that their means are equal. That means that the means are different. So that circle part right there just tells me there's a typo. It should have been 0.866, not the square root. And that you need to not have your data pooled. And our conclusion is a 5% level of significance the data shows below is sufficient evidence to conclude that the mean number of hours of girls and boys ages 7 to 11 play sports per day is different. Okay, so it's different. They are not the same. All right, our next example, 10.3, we have a professor at a large community college wanted to determine if there's a difference in the means of final exam scores between students that took the statistics course online and students that took it face-to-face. Okay, so we have the data from each group, and the data on the top is the online class, and the data in the bottom is the class that took it face-to-face. Okay, so this is very pertinent to what we're doing right now. We want to see if it has a difference. Okay, so we're going to do a two-sample t-test, and we're going to use data. I've already put this information in. I've got my list 1 and my list 2, and then I've got my frequency on both of those is 1. And we're going to see if they are different. Okay, so when we go in there, you'll see that those are going to be different. So we're saying that they're not equal to. And we want to see if the online it actually does worse. So if the face-to-face does better than the online. So the face-to-face looking better or having higher test scores than the online group. All right, so we know we have two means. We don't know the standard deviation, so that's going to give us a student t-test. We're using the differences. Okay, because we're comparing the two groups. We know our null hypothesis is going to say that they're the same, and the alternative is saying that the face-to-face do better than the online. That makes it left-tailed. And when you go through and calculate your p-value, you get 0.0011. All right, so we put that in, 0.0011, that's a left tail, that's the probability of getting that rare event if it happens by chance. Okay, so that tells us it's going to be lower than the alpha, so we're going to reject the null. In other words, the professor's correct. Okay, we have at a 5% level of significance from the sample data, there is sufficient evidence to conclude that the mean final exams for the online are better face-to-face. Okay, so that the scores for the online class are lower and the face-to-face are better. So we reject the null hypothesis because if the p is low, the null must go.